Our final basic derivative rule is if we have something besides just a regular x inside the natural log. So on the last one I told you that one way to remember the derivative of the natural log of x is to cover up the ln and do the derivative of the inside. Derivative of 1x is 1 over the original inside x. So that's the same rule here. So you can memorize that for both types, whether it has an x on the inside or more than an x. What you do is you basically just ignore the ln. It tells you what to do, but you don't have it as part of your answer necessarily. You do the derivative of the inside. Derivative of f of x is f prime of x over the original inside, which is f of x. So for both of these, all you're doing when you see ln is the derivative over the original. Derivative of the inside over the original inside. For both rule 9 and 10, it would work. Let's use that here. We have y. The derivative is going to be called y prime. Automatically, I'm at least going for partial credit here. I'm going to write the original inside on the bottom. X cubed minus 6x squared plus 3 pi. At the very least, I can get partial credit for knowing the original goes on the bottom. And then the harder part is to take the derivative of the inside, so you cover up the ln. Derivative of x cubed is 3x squared. Derivative of negative 6x squared, bring down the power, negative 6 times 2 is going to be a negative 12. X to the first, or just x. And then the derivative of 3 pi, my last piece of the inside, is a constant, so the derivative is 0. So you do derivative over the original. You're more than welcome to pause the video now and try the next one. But even though it's rule 10, it's not the hardest rule, I don't think. So our denominator is going to be the original, 3x to the 5th minus 3x to the 4th minus ln of 3. So derivative of the inside over the original inside. So derivative of 3x to the 5th, bring down the 5 times 3 is 15. X to the 4th, bring down the power again. 4 times negative 3 is going to be a negative 12. X to the 4 minus 1 is 3. And then the derivative of ln of 3 is a constant, so it is 0. So that's rule 10 out of 10. Now that we're super smart and we have all of our derivative rules, which if you remember 2 out of 10 right after watching all 10 videos, then I'm happy with that. So as long as you remember a couple, the more you practice, the more you'll add on to those couple you know. But let's go back to page 14, where we found our first derivative. And we said the derivative of 4x plus 3 is 4. Was that correct? Well, let's see. Derivative of 4x, our mini rule derivative of 4x is 4, and derivative of 3, a constant, is 0. But hey, it took me 1-2 seconds to check that this was the derivative compared to how long it took us to do that 4-step process. So that's why we have all these rules, because it's a lot faster to be able to look at it and be saying the derivative of 4x plus 3 is 4 just by knowing the rules, rather than having to work all these derivatives out using this process.